You're welcome to our mathematics class. In today's class, we'll be looking at indices. Okay? If you're just coming across a video for the first time, please do well to subscribe so you will get more and more of such videos. I teach physics, chemistry, and mathematics. Okay, I would like to have you as my students. Let's go into the classroom. Now, we're looking at indices. Okay, indices is a special topic in mathematics that actually deals with index numbers. Now, we have index numbers as a focal point of indices. Okay, so it deals with operations involving index numbers. What are index numbers? Index numbers are the powers of base numbers. Let's give an instance. We have a number like 2 raised to the power 5. Okay, 2 raised to the power 5 has 2 as its root number and 5 as its index number. I hope you follow. Okay, in other words, we can say 2 raised to the power 5 is equal to 2 times 2 times 2 times 2 times 2. That is 2 into 5 places. We multiply this out, we can have our answer as what? 32. That is 2 raised to the power 5. Okay, now there are other operations we can do using the knowledge of index numbers. Okay, that's applying indices in solving problems. Okay, but before we do that, we'll go ahead to look at the laws of indices. There are laws that guide our operations and mathematical calculations under this topic indices. Now, let's go ahead to look at the laws of indices. Laws of indices. I hope you enjoyed the class. We are looking at laws of indices. All right. Now, the first law we're looking at involves multiplication. Multiplication. So if we have an example like a raised to the power n times a raised to the power n, take note that in this case, a is the root number, while m, n are what? Index numbers. I hope you're following. Now, in such a situation, we can pick, since the base numbers or root numbers are the same, the root numbers are the same, we can pick just one. Okay, this can be simplified to give us a raised to the power n plus n. That is to say, when we are multiplying in indices, okay, we have to add the index numbers. Take note of that. So this becomes the expression that we will have. Let's take, for instance, okay, let's take x raised to the power 5 times x raised to the power 3. Okay, we just pick one of the x and we have what? X raised to the power 5 plus 3, which becomes x raised to the power 8. That's all. That's my answer. The normal method, you can multiply this all through, and we'll still get the same answer. Second law. Second law. We can use numbers here. Take note. We can have 2 raised to the power 2. We can have 2 raised to the power 3 times 2 raised to the power 2. That becomes 2 raised to the power 3 plus 2 equal to 2 raised to the power 5. And that solves it. We get our answer as 32. Let's go to the second law. The second law deals with division. If we have, let's use a different, okay, let's say we have x, okay, raised to power a divided by x raised to power b. In division, we'll still pick one of the values, one of the root numbers here, okay, but we have to subtract the index numbers. That is the second law. Okay, this becomes x raised to the power what? A minus b. For instance, we have 3 raised to the power 5 divided by 3 raised to the power 3. What do we get? What do we get? We get 3 raised to the power 5 minus 3 equal to 3 square, which is what? 3 times 3, which is 9. All right, now let's go to some other laws. This is the first and second law. I want to rub this off so that we can go to the third law. I hope you're following. I hope you're learning something. Um, okay, we're still on laws of indices. Laws of indices. So we go to the third law. Third law deals with negative index. Okay, let's say a number is raised to the power minus one. That's a negative index. Okay, I'm just using minus one. Or let me use another. Okay, let me use minus n. Let's say the power is n. Okay, this is equal to 1 over a raised to power n. Take note, we can have something like this. We can have a raised to power n divided by a raised to power n raised to power minus 1. This can be written as a raised to power n over a raised to power n raised to power 1 now, because we are taking the reciprocal. What we just did here is reciprocal. We took the reciprocal and we got our positive index value. Okay, let's just go ahead. We'll still solve examples relating to this. Number 4 now. Okay, number 4. We have another rule which says an index of 0. Okay, if you have a raised to the power 0, any number raised to the power 0 is equal to 1. Okay, this means that this 1000 raised to the power 0 is equal to 1. Any number, once the index is 0, okay, is equivalent to 1. Now, we have another one, another group. We are going to use all these to solve questions. We have a raised to the power n brackets n outside. Okay, this is the same as having a. These are two powers. Okay, but we'll have to multiply them out. So we have a raised to the power n times n equal to a raised to the power mn. I hope you get. For instance, now let's say 2 raised to the power 3. Okay, we have 2 outside. This becomes 2 raised to the power 3 times, not plus now, please. Okay, this becomes 2 raised to the power 6, which is 64. Okay, now let's go on to the sixth and seventh rule. Sixth and seventh rule. Okay, we've done 1 to 5 rules. We're just trying to go through the rules and then let's know how we can use them to solve questions. All right, I hope you follow. Okay, I hope you follow. So another rule, okay, which we have as the sixth rule. Sixth rule here, we have, if we have an expression a raised to the power 1 over x, okay, this is the same, okay, as having root, okay, of a. This is the number. For instance, we have 27 raised to the power 1 over 3. My 3 is the x here. Okay, this is the same thing as having cube root of 27. Okay, cube root of this. How do we get cube root of 27? We have cube root of 3 times 3 times 3. Okay, my answer is just one of these numbers. So my answer is 3. You pick one third out of that, divide into 3. Okay, if you square it, divide into 2, and then we have pick 1. Okay, now let's go to the last rule, or the seventh. We have other laws of indices. Okay, we can have something like a raised to the power x over y. Let me write this very well. A raised to the power x over y. Okay, now a raised to x over y can be written as, okay, root y of a raised to the power x. This is the power, this is the root. Okay, now for instance, we have 64, okay, raised to the power 2 over 3. This is the same as cube root of what? 64. Then we have a square. Okay, in other words, cube root of 64, we have it as 4 times 4 times 4. Okay, that's equal to 4, and then we bring our square. 4 squared, that will be 16. I hope you're following. So here 16 is our answer. Okay, now let's try to solve just one question. I know we've spent so much time on this laws, but let's try to solve one question, one or two questions. Okay, so that we understand very well. Please follow me. Follow me as we try to solve some questions on indices. Okay, follow me. So let's solve this question. The question says simplify 25 raised to the power 2 over 3, okay, divided by 25 raised to the power 1 over 6 over 1 over 5. 1 over 5 raised to the power minus 7 over 6, okay, times 1 over 5 raised to the power 1 over 6. Okay, this is the question. So I just had to pick it. There's a past white question. I just had to pick it from one of the series. Okay, there's a past white question. So how do we go about this question? Now we have to treat the numerator separately from the denominator. This is the numerator. This is the denominator. Numerator. So we can express this question like this. We can have 25 raised to the power 2 over 3 divided by 25 raised to the power 1 over 6. We'll put in a bracket divided by 1 over 5 raised to the power minus 7 over 6 times 1 over 5 raised to the power 1 over 6. I hope you follow me. Now let's treat this. From the law of indices, we have two root numbers that are the same. Okay, we just pick one. 25. We now subtract minus 1 over 6. Can you see that? Okay, divided by, from the laws of indices, we have the same numbers, we add up the index numbers, divided by 1 over 5, okay, raised to power minus 7 over 6 plus what? Plus 1 over 6. Can you see that? Now 2 over 3 minus 1 over 6. Let's try to get that first. 2 over 3 LCM is 6 here. 3 into 6 is what? 2. 2 times 2, 4. Minus 6 into 6 is 1. 1 times 1 is 1. So this is 3 over 6. 3 over 6 is 1 over 2. Okay, I hope you understand. So that becomes 25 raised to power what? 1 over 2. 3 divided by 6 is 1 over 2. Okay, then divided by minus 7 over 6 plus 7 over 6. Minus 7 plus 1. Since the denominators are the same, that's this, we just solve the numerator. Okay, so minus 7 plus 1, that's minus 6. So we have we have 1 over 5. Okay, 1 over 5 raised to the power minus 6 over 6. I have to rub off one part of the board, so I'll rewrite this so we all understand and see what I'm trying to get. So we have 25 raised to the power 1 over 2 divided by 1 over 5 raised to the power minus 6 over 6 is the same as minus 1. Take note. Now we have to take the base numbers to the same, or the root numbers to the same base. We have to take the root numbers to the same base. In other words, this becomes 5 square, 25. So we have 5 square raised to the power 1 over 2 divided by, we can now take 1 over 5 is the same thing as 5 raised to the power minus 1. So 5 raised to the power minus 1 minus 1. Let's go further. Okay. We may not solve many questions in this class, but in next class we'll solve a lot. So this becomes 2 cancels this 2. Okay, what do we get? We get 5 raised to the power 1 divided by minus 1 times minus 1. Remember, we have 5 raised to the power 1. Can you see that? Minus 1 multiplied by minus 1, because we say we have to open and multiply that, not addition. So this becomes 5 raised to the power 1 minus 1. Division, subtraction of the powers. We have 5 raised to the power 0. Any number raised to the power 0 is equal to 1. 1 is my final answer in this question. Now in the next class, we'll look at more questions on indices. Please subscribe so that you'll see more of our videos. Thank you so much.